Bismillahirrahmanirrahim. In this video, we will discuss about the acids and bases. So you can say that what are acids and what are bases. So you can say, for example, the HCl, this is an acid, the sulfuric acid, and the acetic acid. So we will discuss about these acids step by steps. So we can say these are the example of acids: hydrochloric acid, sulfuric acid, and acetic acid. Now, by definition, we can say that substances that release hydrogen ions in aqueous solutions are called acids. This is the proton, you can say hydrogen ions. So the substances which releases hydrogen ions in solutions, these are called, I can say, acids when the same is dissolved in water. For example, we can say that if we add hydrochloric acid or HCl in aqueous solution, you can say which is water, so it will give H3O hydronium ion plus Cl chloride ions. So we can say that this HCl is being ionized in aqueous solution to produce H plus. I can say this is the combination of H plus and chloride Cl minus. So when we put it in water, it gives hydrogen ions and chloride ions. So we can say the hydrogen ions, so this combines with the water to produce hydronium ions, and you can say the chloride ion is released in this form. So we can say it is proved that the HCl is an acid because it has given a hydrogen ion which combines with the water to produce hydronium ions. So we can say that HCl is an acid. And on the other hand, the HCl is a strong acid because this acid is completely dissociated in aqueous solutions, you can say water. So this is the completely dissociation in water. So we can say that HCl is a strong acid. This is a strong acid because it dissociates completely in a aqueous solution. So on the other hand, if you see the sulfuric acid, it also has the same behavior, but it has two hydrogen atoms. So we can say, so we have sulfuric acid. This is also a strong acid because sulfuric acid is completely dissociated in in aqueous solutions. So if we put it in water, so you can say the sulfuric acid will be dissociated completely in, you can say, H2O. This is water, H2O. So it will give. So we can say that it has, if you see here that sulfuric acid is two hydrogen atoms instead of one, like HCl. HCl has one hydrogen atom, while the sulfuric acid has two hydrogen atoms. So you can say that so you can say it will give two hydrogen ions plus this is the two hydrogen ions instead of one, because sulfuric acid has two hydrogen atoms, and it will also give sulfate, and sulfate is the valency of -2 because when sulfuric acid is dissociated, it gives two hydrogen ions and one sulfate. So we can say that sulfuric acid is also you can say that it will a strong acid it is completely dissociated in water. or we can say, if we see the case in case of sulfuric acid. So if you see step-by-step reaction of sulfuric acid with that of water, so we can say the reaction of sulfuric acid is completed in two steps. So in the first case, we can say that sulfuric acid plus reaction mixed in water. So we can say that in the first case it will release one proton, which is H plus, and this one proton plus H hydrogen sulfate, and it has valency of -1. So we can say this is the first step number 1, and we can say this is second step 2. So in the second step, this sulfate, hydrogen sulfate, is further dissociated. HSO4, we can say this is further dissociated in water because it also contains water. So it again produce, and this is we can say that will gives H3O in the form of hydronium ion, and this will also give hydronium ions in the form of H3O. I can say this is with a combination of proton and water produces hydronium ions. So and it will produce sulfate ions. So we can say that it will have -2 charge because two protons have been released from sulfate ions. So therefore it has -2 charge. So you can say the dissociation of sulfuric acid is being completed in two steps, and in the first step it releases one hydrogen, and in the second step it also releases second hydrogen. So we can say it releases a total of 2 hydrogen atoms. So therefore we can say that sulfuric acid is a strong acid and it is completely dissociated in water. So always add we can say acid into water, but not water into acids, because it will give dangerous reactions when you will add water into acids. So we can say that sulfuric acid is strong acid. So similarly, if we take example of acetic acid, this is acetic acid. So we can say that acetic acid is not a strong acid. It is an acid but not a strong acid. It is a weak acid because it is partially dissociated in aqueous solutions. So we can say that this is the acetic acid. If we add it into water, so we can say it will also give acetate ions plus H3O, we can say, and H3O means that addition of one hydrogen ion plus H2O, and that will give hydronium ions H3O. So we can say this hydronium ions is this one. So we can say that when acetic acid is added into water, we can say that it will give hydronium ions plus acetate ions CH3COO. But here it is to be noted that this acetic acid is still not completely dissociated in water, and it is partially dissociated in aqueous solution. So you can say that therefore acetic acid is a weak acid, not a strong acid, because it is partially dissociated. So therefore it is a weak acid. Now we will discuss about the bases. What are bases? Previously we have discussed about the acids, so now we can discuss about the bases. Now we can say that bases are those which release OH ions in aqueous solution, that is called a base, or we can say acceptor. We can not release hydrogen ions, but release hydroxyl ions. So you can say, so these are the acids, bases. So for example, we have sodium hydroxide. This is example of a strong base. because when we add it in water, so you can say it will gives sodium ion plus OH ions. So as it is it gives OH ions, so you can say that this is the base because it produces OH ions in aqueous solution. Or if similarly, potassium hydroxide, when it is put in water, so it also produces potassium ions plus OH ions. So you can say due to this OH ions, you can say that potassium hydroxide is a base. Similarly, ammonium hydroxide, ammonium NH4 H, this is ammonium hydroxide, when we put it in water, so we can say that it will also use OH ions, due to which we can say that potassium hydroxide is a base because it produces OH ions in aqueous solution. So these are the bases because they produces OH ions in aqueous solution. Theories about acids and bases. So there are various theories about acids and bases. So the first one is Arrhenius theory. Arrhenius theory says that acid is that one which produces hydrogen ions in aqueous solution. As we previously discussed, that the acids gives H plus ions in aqueous solutions, so therefore these will be acids. While according to Arrhenius theory, bases are those which produces OH ions in aqueous solutions, and that will be the base. Such as we have said that NaOH, KOH, etc. these are bases, while the HCl sulfuric acid, and I can say these are produces H ions in aqueous solutions. So according to Arrhenius, these are the acids, and these are the bases because it produces OH ions in aqueous solution. So this is the concept of Arrhenius, and this concept was proposed for the first time in 1887 by Arrhenius. So the second one is a Bronsted-Lowry theory. We can say, according to this theory, an acid is a proton donor while the base is a proton acceptor. So we can say, according to Lowry-Bronsted, acid is a proton donor, while that of the base is the proton acceptor. So this is the base according to Bronsted-Lowry concept. So this is the example of HCl with the you can say reaction of HCl with the water. So it produces hydronium ions and chloride ions. So in this case, we can say we have known that acid is those which is a proton donors. So you can say in this case, according to the Lowry-Bronsted concept, the HCl is an acid because it will give proton to the base. You can say this water will accept a proton from the HCl. So as HCl gives a proton to the water, so you can say that HCl is an acid according to Lowry-Bronsted concept, while that for the water is a base. So we can write here that HCl is an acid because it gives this hydrogen ions, and water is a base because the water accepts this hydrogen atoms from we can say from HCl, so to produce this hydronium ions. So we can say this is the hydronium ions, and also it's these chloride ions. So this is a chloride. So according to Lowry-Bronsted concept, we can say that HCl is an acid because it gives proton. Well, the base is that which accept proton. So in this case, we have water. So water accept proton from HCl. So you can say water is a base according to Lowry Bronsted concept. So you can say Lowry Bronsted concept about acid and bases is limitations because it doesn't explain the CO2 which is either acid or base. You can say sulfur dioxide. It is not explained by the Lowry Bronsted concept because if you see the CO2 which does not give hydrogen ions, or you can say except hydrogen ions or protons. So Lowry Bronsted did not explain the CO2 which is either acid or base. Similarly, Lowry Bronsted also not explain the sulfur dioxide which is either acid or base because it neither gives hydrogen ions or neither accept the hydrogen ions, you can say protons. So these are the limitations of we can say Bronsted-Lowry concept about acid and bases. Now we see that here water is the base, but water is also behave like an acid and a base also. So we can say that the substances which behave like both as an acids or bases, these are called amphoteric substances. You can say amphoteric substances. So in this case, water is also an amphoteric substance because it behaves both like an acid and base. So in this case, in the example, you can say this one. Here the water behave like a base because it accepts proton from HCl, while in some cases water instead of accepting protons, it gives proton. So you can say that this behave like amphoteric substances. So it is also water is amphoteric substance. For example, in the case of ammonia, NH3, we can say that this is ammonia, and here. Now this example, you can say this is the ammonia. This one is ammonia and this one is water. So in this case, the water is donating the hydrogen ion into the ammonia. So here water is denoting protons. So it means that water behave as an acid, while that of ammonia is accepting this proton. So you can say ammonia behave as a base. So we can write here that is water is donating protons. So you can say that this is an acid, while that of ammonia is accepting protons. You can say this is the base. So in this case, we can say that ammonia acts as a base, so while that of water acts as a acid, and we can say that water is an amphoteric substance because here the water acts as an acid. And in the very example here, if you see that water is a base, so water behave like acid and base, so therefore water is called amphoteric substance. So here we will explain the properties of acids and bases. So we can say that first if you see the acid and we can say bases, the properties are like this, that acid has sour taste, we can say sour taste of acid, while that of bases has we can say bitter taste, bitter taste. Similarly, acid is you can say corrosive in nature, while that of base is slippery. When it is touched, it turns blue litmus paper to red, while you can say the base turns red litmus paper to you can say red litmus paper to blue. So this is the properties of water. Similarly, we can say that acids have pH you can say less than 7, while that of bases have pH greater than 7. So these are the properties of acids and bases which differentiate them with each other. Reaction of acid and base. The reaction of acid with the base always use neutralizing reaction and produce salt. For example, we can say that we have a base sodium hydroxide. When it is mixed with the HCl, so these both are strong bases and acids, so it will produce sodium chloride, which is a salt, and a water. So this is also called this is the base, and you can say strong base, and this is strong acid, and it will give salt and water. So this is called neutralization reaction between acid and bases. Now remember that always add acid into water. I can say acid into water, but not water into acids, because this is highly dangerous when you add water into acids. So you can say, so always add acid into water, and this is safe, you can say recommended, while not add water into acid. So because this is dangerous, so follow. So this one, add acid into water.